Vectors. If you want physics in a game, you pretty much have to use them. So, here's how they work.
Ow! I'm studying! I promise!
So a dot product is a useful way of comparing two vectors to see if they're going in the same direction and how much they're going in the same direction. So if they're both the same length, like a normalized vector, then if they're the same direction, exactly, you get an answer of 1. If they're going opposite directions, then it's -1. If they're going 90 degrees to each other, then you get a 0. And then you get some kind of variance between -1 and 1, depending on the angle that you have. And the answer is always going to be somewhere between 180 and 0, because you can't tell if it's going left or right, because that's just not how the math works out. So one of the useful things with a dot product is that if you have a ball bouncing off of a wall, then you know which angle and how much has to be changed in the velocity of the ball in any one direction, so that you can actually make it look like it bounces properly. So a cross product is kind of like a dot product, where it compares two vectors to get an angle. But instead of it just being a 2D environment, it will actually switch things to a 3D. So you get a vector that actually points in the 3D plane upward or downward based off of the angle that is between the two normalized vectors. And this also gives us the ability to look at, is it to the right or the left? It can't determine front or back, but the dot product does that part for us. So the overall length of the resulting vector ends up being equal in comparison to the angle between the two vectors itself. There's a simple trick we use in order to figure out which direction the vector is going to point. So if you take your right hand, this vector ends up being the first vector, and then you compare it to this vector, the result is always up. If you rotate it around, so the original vector is this way, and if you compare it to one on the other side, now the vector is down. This is called the right-hand rule. So the cross product can be useful for beyond just having left or right side. If you have two objects floating around and need to rotate around a single point, you can use the cross product to figure out what that axis is, so you can rotate it around that axis. If you want to move things between 2D into 3D, you can now determine which way is up, for example. So vectors are floating point math, so we have to worry about precision issues that we have along with it. So in most cases, we have 24 bits of precision with an 8-bit exponent. What that means is you have a number like 1 million. It's actually stored as 1 times 10 to the 6th power. So if you start adding in things like 0.0001 and 1 million, we start actually not being able to store that value with 24 bits. And we start actually losing information. We have to kind of worry about how that math works out, and if you're not careful, you can easily have things not move across the screen. So for moving an image from one place to another, the easy thing is it has a center position. We just move the center position by a vector, and you can get whatever effect you're looking for from moving from one place to another. Simple stuff. So the use of dot product and cross product is to take an image that's 2D that's always pointing to one direction and rotate it so that it aims at a target instead of just always off to one particular side. So if you have a known direction, you can use that as a vector and then compare it to a vector to the target, and then you have an angle that you need to rotate the actual image to. So you can take the dot product in order to get how much from front to back rotation, and then you use the cross product to determine if it's left or right. You can set a maximum rotation speed of an image by comparing the attempt at a rotation to an actual value by comparing the dot product in order to calculate the angle, and in order, if it's beyond whatever the limit is, you cap it off. If I have a first-person style game, I can use a vector based off of the controls given by a user, like a joystick or keyboard controls, and then convert that movement into actual movement from my own center point. So left, right, up, down, easy controls. If you're looking for kind of movement inside of a game world, even like a top-down, like a grid system can use this by having the grid itself be the XY coordinates, and you can kind of work with the overall length to determine how many squares they can move, for example. If you're not using grids, you can open space and use a vector for any directions based off of the actual user controls. So when dealing with vehicles, sometimes you have to have a vehicle that only rotates while moving forward, like a car or a boat. If you have like a helicopter or hovercraft, you can rotate without moving forward. So you can have limits for rotation per second as it's moving forward, or you might have a rotation per second without having any movement whatsoever. And inside the control system, you might have a maximum value, and you might have some minimum value as well. So the car has to continuously move forward. So you get into these areas of curve where you can have maximum minimums and then somewhere in between as well. If you're working with some kind of vehicle, usually there's some kind of momentum vector along the way. So if you're moving forward, you're going to continue moving forward until you apply some kind of change, like a brake or accelerate more. Only problem is that when you start working with addition of vectors, you might have to worry about having your vehicle travel too fast, have too much momentum. So you might have to work on capping your actual overall momentum in some way. So you get the length of a vector, you see if it's a particular value. If not, you reduce it back down to maximum and then multiply it by the maximum. Now you've capped the overall vector length. One of the other ways of working with vectors in physics is to actually just apply forces to an object. So you have force and mass, and it ends up being some kind of change in the overall momentum of an object. This is a whole other video that I'll get into the next one. But in physics games, time is a major factor. You've probably noticed that a lot of games have a frame rate that kind of varies a lot, and then the game doesn't seem to notice or care. Well, that's because they've been timing the overall momentum of an object by the amount of time in the individual frame. So you have variance in the frame, you have variance in the amount of time that you multiply your movement by. And you can do that either by having a very static FPS that you have in every frame. So every frame equals 10 milliseconds, for example, and then the next frame is always 10 milliseconds, whether it actually took that long or not. Or you can make it so that you are measuring the actual time between each individual frame, and then you have an actual value that you've calculated, which you multiply the overall length of any kind of movement by. The problem with this is that sometimes the frame can take an excessive amount of long time because computers naturally stutter. So when the game stutters, you're going to have some kind of issue where the physics was thinking something would be less than 100 milliseconds, and all of a sudden it ends up being 2 or 3 seconds. See, those are the type of videos you might see on YouTube where a boat in crisis all of a sudden starts rocking from side to side and then just starts rolling through the world. Or a character in a game starts flopping all over the place and with backwards arms. This type of things happen. So you have to be careful when you're working with time units and multiplying vectors, because you have to make sure that there's a minimum and a maximum value that you are willing to assign. And then if it's beyond a certain value, just accept that the game's going to stutter, and then players are going to notice that. The general concepts to work with when you're working with vectors is things like keeping things simple as possible. You can make it a lot of different vectors all over the place, but sometimes just one is good enough. That kind of works with most games in general for non-vector stuff too. If you're working with vectors, you also want to make sure that you kind of work with it so that you expect it to break. So if you might have a vector that's a length of 0, now you have no idea which direction it's going, so you kind of have to make sure that you don't have those minimums below a certain threshold. Or if you're working with a high FPS rate, then you have to worry about, hey, does my precision actually support the amount of movement that's needed? If it's a slow object and a really high FPS, well, now you might start losing information. You also have to worry about things like time. Is it stable? If it's not, then you have to start working with some kind of min-max for time as well. When working with time and vectors, one of the things to worry about is it consistent, but also what's the actual window of time you're working with? Not just for precision, but the actual forces that you're applying will feel different if you have a very short time window or a very long time window. So you might want to try out different time frames, have different frame rates to see how your game feels and see if it actually matches. The other one is if you're actually working with time and you're finding that the engine kind of does weird things, if it ends up being too high of a frame rate, you can always cap that value at something. This is why a lot of games have a max physics cap rate of like 100 frames per second. Usually it revolves around the actual imagery, but it's because the physics and images are linked together precisely. If you're not working with them linked, sometimes you still have to cap that physics value, otherwise everything starts to break. If you want physics in a game, pretty much have to get used to vectors. Sorry.
Ow! I'm studying! I promise!
Remember that it's like 1 million is not stored as 1 million in a float. It's stored as 1 plus an exponent, like 10 to the 9th. So, yeah, 10 to the 9th.